Okay, quick update to recap the math class that I had this morning. Today I had period 1, 2, and 3. Period 1 for me was math, and periods 2 and 3 were history. Tomorrow I'm going to have period 5 and 6 for math also. So if you're in period 5 or period 6 math class, this is actually a little bit of a lesson that's ahead of what we're going to be doing. Now, in period 1 class this morning, went over a lot of the stuff. Cabinet has the assignments posted, so please watch that and take a look at that and read it and pay attention to it. First part of it, 1. You're going to have the zombie geometry assignment, which is starting, which basically starts off with you making a list of 10 items you would have with you in a zombie apocalypse. Any kind of items, can be anything you want to. There's very few restrictions on these items at this point. You don't have to own these actual items. You can just make a list of any 10 items you want. Something you think would help you get through, to live, to survive. This is an activity game we're going to play. Usually I play it at school in the classroom. It's much easier. We're going to try and do it remotely this year just because I don't want you guys to try and miss out on it because it's kind of fun. Of this first step of the assignment for zombie geometry, you make a list of 10 items first, and then we discuss it in class. When you make the list of 10 items, throughout your house you have to look for a container or something where you would store all of your items. Now this could be a bag, a box, a closet, a purse, a pair of shoes, a pair of pants, I don't care, whatever you want to have for your container. Choose a container though that you think you'll be able to measure the dimensions for. You'll need to be measuring the dimensions. For example, if you chose a cardboard box and it happened to be like a cube, so you have to be able to do the length, the height, and the width, or a rectangular prism, something like that. If you choose a duffel bag, it's roughly the shape of a cylinder. So you'd be looking for the length of it, of course, and the diameter of the circle on the end of it. So those things are going to help you calculate how much area or volume you may have to work with depending on what your container size or shape is. So 2 things for this first part of the assignment. 1 is a list of 10 items you take with you under a zombie apocalypse, and 2 is the container itself. Could be the trunk of your mom or dad's car. Also, it doesn't really matter. However, the total number of items in your list is 10, but the total weight of all the items added together cannot exceed your own body weight. Therefore, if I was doing the list, I weigh 155 pounds, so I can only do something that add up to be a total of 155 pounds of weight. Now, that being said, when you have those amount of weights there, it can also has to fit in your container size. So that's what we'll be checking out next class. So first part of this assignment, when you have math class, is going to be a 10-item list. And second part, of course, is choosing the container itself and then measuring it. And then we'll go forward from there. This does turn into a game that requires you to solve certain things, math challenges and stuff to get by to see if you're able to survive the activity in the game. Now today in class, for our next chapter, we're going to start off talking about data collection and graphing. Now graphing, of course, have been surrounded by graphs recently with the COVID-19 virus. They've talked about different flattening the curves and things like that. So let's take a quick look at something like that. So if you have your basic quadrant graph, you have 4 sections, okay? Each one of these represents a line that goes on forever, okay? It goes on and on, expands. Basic geometry we talked about, a line keeps on traveling and doesn't end. Now, the center of this is called the origin. The origin represents a pair of numbers for x and y coordinates, which x is my horizontal coordinate and y is my vertical coordinate going up and down. Now, the center represents 0, 0. Okay? That, of course, is going to be the origin, where everything is right there in the middle. Now, to go a little farther, let's say I wanted to have a dot at something we call 1, 2. Over 1, up 2, and there's my dot. Over and up. You got to run before you jump, okay? So essentially, you're always doing the x-coordinate first, which is horizontal, and then your y-coordinate second, which is going to be vertical. Since these are both positive, I go to a positive number and then up. If I'm going to do something like -3, -2, that goes -1, -2, -3. Okay? And then I have to go down -2, -1, -2. And that would meet right about there. Okay? So this is your basic x, y coordinate. This is nothing new that you haven't seen before. This is lower school math. You've done ordered pairs, you've done quadrant graphing. This is just the first step into it. Now, when we're doing data collection and things like that, you're collecting data. You're looking for information. You're graphing it out in a form that can help you follow things. Keep in mind, you can talk to people all the time, but sometimes a visual representation of a graph or of information has a much heavier impact on people rather than just your words alone. Okay? Words can sway people, but images stick around a long time for people and can also, think about a lot of people, short attention span, not really listen to a lot of things people are saying. You flip a page, you look at the pretty picture, oh, look at the colorful graphic, oh, and you kind of get the message. Example. If I took just this portion of a graph and took it out, just that one quadrant, okay, and let's say this is going to be people, and this is going to be time. So like you've seen the graphs on TV where they talk about number of infected people, how many people tested positive for a virus, or something like that. This is a pretty straightforward example. Now, this example comes along this. Let's say this is in thousands of people. For every line, this is another, like say, 1,000 people. So 1,000, 2,000, 3,000, 4,000, 5,000. You get the idea. Now let's say down here it's time. So let's say this is going to be January. Let's say this is going to be February. Let's say that would be March. And let's say that would be April. Now, I'm going to give a loose interpretation of a graph. I'm not going to use any actual numbers, but I'm going to give basically an overview about how a graph could be used and how it can see things. You've heard about this flattening the curve all the time, right? So basically it goes like this. It's a kind of twofold mathematical understanding. Let's say in January, you had 10,000 sick people. Let's say by February, you had 30,000 sick people. Let's say by March, you had 50,000 sick people. And let's say by April, you had 80,000. Okay, if I look at this as a graph, you see it's continuing to increase by a pretty high rate. Okay, that's not the really big story there. The thing that you want to understand with this graph is it easy to follow along? Yeah, I can see it growing rather high and getting really big as time moves on. But the other thing is this. If I draw a line connecting them, I get this increase of this line, what's called a trend line. It's trending upward. Now, if this was your bank account, you would totally be, whoa, this is awesome, because you're making more and more and more money. But since we're talking about sick people, it's not so awesome because you're not making more and more and more money. All right? If this was time off for vacation and it's going higher and higher and higher, you'd be like, yes, this is sweet. But if it was unemployed people, that wouldn't be so cool. So it gives you an easy visual way to represent information for people to understand. That quadrant graph here is taking just this portion of that part with the positive and positive numbers and putting it here to give you a way to see it. Now let's say if you extended that graph and then eventually, instead of it just keep going up like that, you would get something like this. And it would come down. Now it might be longer or it might be shorter. If it's short, it might be a really pronounced right like that. If it's longer, it's probably going to be a more gradual decline like that. Now I've got lines all over this, which is kind of weird, right? But you kind of get the idea. When you stretch something out, the curve gets flattened. It doesn't get to be like this big hump. And that's what they're talking about when you hear flattening the curve, okay? They're talking about, hey, let's prevent all these things from spiking at one time and kind of spread it out over a longer period of time, which makes good sense because you don't want to overwhelm your services. Now, how this relates to our math and our graphing, exactly the way I just did. You're able to follow something visually, a fair amount of information that's calculated and collected in a variety of different ways and put together in a fashion that even people that don't have a statistics background or knowledge of things like that or have seen all the measurements and things like that can make sense of. Now, here's the flip side. Let's say the data put in your graph isn't true. Can that mislead people? Yeah, it can. And that's where it gets tricky. Let's say if I am asking a group of people an opinion about a law, but I'm only asking a group of people in a certain state, in a certain neighborhood, that all make or have the same kind of jobs or make the same kind of income. That means their opinions may be all pretty close together. So then you could put together a graph and go, look, 98% of the people agree with this. but it doesn't represent the rest of the sample size. And that's the trick. You've got to get a good sample size to get a true reflection or representation of these things. And that's where statistics come in. If you ask one person a question, that's a really small sample. If you ask 30 people a question, it's a better sample. If you go around to 3 different neighborhoods and ask 30 people, that's 10 people in each neighborhood. That's a pretty good sample, okay? If you do that among 3,000 people or 30,000 people across 30 states, that might be even better, depending on what information you're looking for. Now, could you use this knowledge and your knowledge of math to create a graph or a survey or a poll that reflects your own decision or your own information the way you want it to be shown? Yes, you can. 9 out of 10 dentists recommend this toothpaste. Sure, which dentists? Which 9, which 10? Is it the 9 out of 10 dentists that I wrote a $10,000 check to? Mr. Bowman, you're indicating there could be a little bit of dishonesty in statistics and polls and surveys? Yeah, you can manipulate numbers any way you want to, so you got to really be careful and look where those numbers are coming from. It's a tricky, tricky thing. But I think you'll have to agree that as you look at these things, it definitely makes a little bit of an impact. So when we move into quadrant graphing, the quadrant graphing, the order pairs is the first part we'll be looking at. And when we have our next lesson, I'll be sharing a screen full of information, actually going over some lessons with you. But it's about interpreting data, gathering information, and putting it together in a way you can actually look at it, see it, and it become beneficial. Graphs are powerful. A lot of times computer people use graphs and the computers do the graphs for them. Back in my day, uphill to school both ways, in the snow, that sort of stuff. We used to do graphs and they have to do it all by hand. So yeah, that was kind of our thing. Remember, I'm pre-internet, so that reaches back pretty far there. Okay, so this is just a quick overview of what stuff we talked about in class. Hopefully that'll kind of jog some of your memories a little bit right now. For right now, though, the only thing we're looking at is a 10-item list for zombie geometry and the container size with the dimensions. Okay? I'll see you guys. Have a great day.